We all remember learning how to multiply two-digit numbers when we were in school, the old-fashioned way. We'd start by multiplying 8 times 6 to get 48, put our 8 below the 6, carry our 4. Then we'd multiply 2 times 6 to get 12, add that 4 to get 16. We'd put a 0 below the 8. We weren't really sure why, but our teacher told us to do it, so we did. Then we'd multiply 8 times 4 to get 32. We'd put our 2 below our 6. We weren't really sure what to do with that 4, but we'd go ahead and add our 3 to the mix that we carried. We'd multiply 2 times 4 to get 8, add 3 to get 11, and then we'd add those two numbers together. 8 plus 0, 6 plus 2, 1 plus 1, and our final answer is 1,288. Chances are, if you have a student learning multiplication right now, they're not bringing home something that looks like this. They may be learning something called partial products, which is leaving you wondering, WTF? So let's take a look at partial products. We're going to solve the same problem in a different way. So we're going to start by breaking each of our factors, so the numbers that we're multiplying, we're going to break those into tens and ones. So 28 is equal to 20 plus 8. 46 is equal to 40 plus 6. Then what we're going to do is we're going to multiply 20 times 40, 20 times 6, 8 times 40, 8 times 6, and when we're done, we're going to add all those numbers together. So let's start with 20 times 40. So that multiplication is pretty simple. 2 times 4 is 8, and then we have to add our 2 zeros to get 800. Now let's multiply 20 times 6. Again, pretty simple. 2 times 6 is 12, but we have to add our 0 to make it 120. Now let's multiply 8 times 40 and 8 times 6. So 8 times 40, well, 8 times 4 is 32. If we add in our 0, we get 320. And last but not least, 8 times 6 is just 48. So our multiplication wasn't too hard, and now our addition isn't very hard. We're going to add those four numbers together. In the ones place, we just have 8. In the tens place, we have 4, 5, 6, 7, 8. And in the hundreds place, we have 8, 9, 10, 11, 12. So we have 12 hundreds. So our answer is 1,288. So this may look like a lot more work than the traditional method, the old school method that we're used to, but it does have a couple of advantages. So to start out with, none of the multiplication is very hard. You're really just multiplying single digit numbers together and then using some zeros for place value. It does teach students place value because they understand why they're multiplying and adding those extra zeros, whereas they might not understand that with the traditional method. Also at the end, our addition is typically very easy. So all of that combined means that students not only understand it better, but they also tend to make fewer mistakes with this method because they don't forget to add a placeholder 0, they don't forget to carry, they don't forget to add what they carried. So it just ends up with a lot more students getting the correct answer a lot more often. Let's look at another example. So we have 49 times 52. We'll do 40 plus 9 and 50 plus 2. And we're going to do the same thing. So let's start by multiplying 40 times 50. Now we know that 4 times 5 is 20, but don't forget we have to add 2 zeros still. So we're getting 2,000, not 200. Now let's multiply 40 times 2. And of course we get 80. We'll multiply 9 times 50. And so 9 times 5 is 45, plus our 0 gives us 450. And last but not least, 9 times 2, which is just 18. We're going to add those four numbers together. Our ones place is just 8. And our tens place, we have 8 and 9, plus 5 is 14. We will go ahead and carry that 1. 1 and 4 makes 5, and so we have 2,548. Now, there are a couple of times when we really don't want to use partial products. So it's a good method, but we always want to choose the best method, and it's not always the best method. So the first example here is 12 times 12. Could we go ahead and do 10 plus 2 times 10 plus 2 and do our 4 products and add it together? Yes, we could. We'd get the correct answer. However, that's just a basic multiplication fact. 12 times 12 is 144. We can just memorize that and be done with it. Not a good time to use partial products. Another time when it's not good to use partial products is a problem like 534,718 times 3,992. Again, could we use partial products here? Yes, but is it going to take a really long time and a lot of paper and a lot of patience? Also yes. Students will learn the traditional method eventually, and that would be a much better choice for this problem, but the ultimate best choice for this would be to use a calculator, because let's be honest, we can't make the statement anymore that students will not always have a calculator in their pocket, because with smartphones, they will. So we really don't want to use the partial product method there. So I hope that helped to understand the partial products method a little bit better. If you have any questions about your child's homework that leave you wondering WTF, please leave a comment down below and I will respond to it in a future video. Thanks for watching and have a great day.